Okay, consider the composite function x squared minus 2. Describe two operations in order that can be applied to x to get to x squared minus 2. If you were describing this in English, it consists of two steps. If you start with the number x, the first step is take that number and square it. The second step is subtract 2 off it. So you can think of those as two separate functions if you wanted. You could say the first function is just square it, and the second function is simply, x minus 2. So if you had to take this function and break it up into jobs for two people, you'd say, okay, first person, square whatever number you're given, and second person, take whatever number you're given and subtract 2 from it. If you had these two guys working side by side, overall they would be taking numbers, squaring them, and then subtracting 2 from them. So working together they would end up doing h of x. The first one would do the squaring part, the second one would do the subtracting part. So what they're after here is x gets squared and turns into x to the 2, and then 2 gets subtracted from it, and after that you've got x squared minus 2. So let's see, if they have two functions, the first one is the squaring, and the second one is the squaring's already been done and we're just subtracting 2. This is a weird sequence to put this in. I kind of don't like this last line, but they're saying the first function just does the squaring, the second function just does the subtracting of 2, and so this part, this is the big finish, says if you take that second function and give it a number that's already been squared, the result is x squared minus 2, which we already said. This is just a kind of convoluted mathematical way of expressing it. Compositions are not this hard, and we don't normally talk about them this way, so if you're a little nonplussed by this example, don't worry too much about it. They're just trying to hammer in the point that this function is made of two pieces and it's possible to consider them separately.